Welcome back, everyone, to our continued discussion on dealing with missing data. In part 2, we're going to talk about filling in data for rows. Recall, we just calculated the percentage of data missing per feature column. So here we can see that on the right-hand side, there's a couple of features where most of the rows in our data set have a null value for that particular feature. That could indicate that we want to later on drop that entire feature column if most of the data doesn't have information on it. Or maybe there was a mistake in the way the data was filled in, and null values are actually going to be some other default value, like a 0. So we'll have to take that into consideration later on. But really what we want to focus on right now, when we're talking about rows, are the features where we are not actually missing that much percentage. So let's first work on considering features that actually have a very small percent missing. Over on the left-hand side here, I can see things like electrical, garage area, total basement square feet, etc. have very small percent of values actually missing. And so essentially what that means is there's only a few rows where we're going to have to make a decision. So in the case of just a few rows missing that particular feature data, we can consider either dropping these few rows or filling them in with a reasonable assumption based off domain knowledge. What I want to do is jump to the notebooks now to explore our options for these particular features where we're just missing that data for a few rows. Let's head to the notebook. All right, here I am at the notebook. Here's the plot we created last time. I went ahead and created a larger figure size and sharpened it a bit. But in general, we can see that we have quite a few features that the actual percent missing is quite small. And what you should do is have an honest conversation with yourself and whoever your domain knowledge expert is in considering the fact that maybe for some of these rows that we're missing this data, where there's data for most rows, that is to say the percent missing is not that high, we should set ourselves some kind of threshold where it will begin to be okay to drop rows. So what I mean by that is let's set the y limit here to be from 0 to 1. Recall that the y limit right now is in percent. So it's going from 0 to 100% of rows are missing that data. Obviously, we don't have straight 0 for any of these features. We also don't have 100 for any of these features. All of these features are missing some data and have some rows that have some information on it. But let's go ahead and just only consider rows where the percent missing is somewhere between 0 and 1%, because I'm probably not going to mind dropping 1% of my data. Obviously, it depends on the context in your particular data situation if you're okay to drop 1% of your data, but with 3,000 rows-ish, it should be okay to drop about 30-ish rows at a maximum. Anything more than that, and I should probably start trying to figure out how to fill in those values instead of just dropping them. So if we set our y limit to 1, I can see here that many of these features are past 1% missing. So I'm kind of just artificially choosing a threshold where any feature where the missing percentage is less than 1 is going to be okay for me to drop. That doesn't mean I have to drop them, but I'm essentially setting myself for a maximum value, which essentially means I'm not going to be able to drop any of these rows just because they're missing one of these features. However, we can see here things like electrical, garage area, total basement square feet. It's such a low percentage of rows that are missing it that it may actually make sense maybe to just drop 1 or 2 rows, especially if later on we notice that it's just 1 or 2 houses that are actually missing all this information. So essentially what I want to figure out is which rows are missing these very small percent data features. So what I'm going to say is, recall we have percent nan, and I'm going to check the percent nan where it's less than 1. Essentially asking the question, what are these features that have the percent missing less than 1%? And here they are, electrical, garage area, etc. It's basically these features right here that aren't past that 1 limit. It's just the straight series of this visualization. And at this stage, I would encourage you to just start exploring what actual percentage is 0.034165. And in fact, if you essentially reverse something and say something like 100 divided by the length of the data frame, you will realize that 100 divided by the length of the data frame is exactly 0.03416, the exact number shown here. What is that actually telling us? It's essentially telling us that only one row is missing information for electrical. Only one row is missing information for garage area, etc. So in fact, all of these percentages is just significant for one row. it will probably make a lot of sense to drop that one row. However, we don't know yet if it's one row for electrical, another row that's separate from that for the garage area that's missing, another row separate for total basement, etc. So we'll have to begin to figure that out. And here we can also then begin to see that 0.06832 is the doubling of 0.034165, which means it's essentially just two rows that are missing basement full bath and basement half bath. Let's go ahead and explore just one of the rows that's missing, for example, electrical. So I can say something like, for the entire original data frame, give me back the data frame where electrical is null. You run that, and it's going to report back some particular ID. And I can begin to see that it's missing other values, but it doesn't look like it's missing things like garage area. Let's take a closer look by checking what the value is for garage area. You run that, and you can see that this one actually does have the garage area, which means this row for electrical that has electrical missing is not the same as the row that has garage area missing. But let's check out something like the one that's missing basement full bath or basement half bath. So what I'm going to say here is check where my data frame happens to be missing basements, make sure we spell this right, half bath, and where is that null? All right, now as expected from this result, I can see that I'm missing basement half bath information for these two particular rows. And essentially now I have to begin to decide, am I going to fill in these values or am I going to just drop these rows? And either approach in this particular case is probably pretty valid. It's not a big deal to just drop two rows of information. More often than not, you're going to try to retain as much data as possible, but it wouldn't be too bad to actually drop these rows. When we're thinking about dropping rows, it's probably a good idea to start from the least percent missing to higher percent missing. All of these particular features happen to be missing less than 1%, easily within our kind of arbitrary threshold of being able to drop a row if it falls into one of these low percent feature missing columns. So what are we going to do then? Well, what I can do is I actually know that the row that is missing electrical is not the same as the row that's missing garage area. So there's a single row missing electrical and a single row missing garage area. And recall, I know this because of this line right here where I checked for the data frame where null is missing. It was index 1576, and it did have a value for garage area, meaning that there's another row missing garage area. So what we're going to do then is the following. I'm going to say my data frame is equal to df drop NA, and along axis is equal to 0 because I only want to drop rows. I'm going to say consider the subset equal to electrical and garage, whoops, make sure we put that in quotes, garage cars. So what am I actually saying here? I'm saying for the entire data frame, only take a look at the rows where we're missing the value for electrical or we're missing the value for garage cars. So look at the rows of axis equal to 0, and recall that I already know percent-wise, there's only one row missing electrical and one row missing garage area. And hopefully when we drop those two rows, we also end up taking a lot of this down with us. Let's see if that happens to be the case, this bad seed of data. So we're going to run this. And then what we're also going to do is recalculate this %nan because we've affected our original data frame. And recall we have this %missing function. This is kind of one of the main reasons we created this function, is so that I can continually update how much percentage of data am I missing. So run %nan, and then what we can do is check where's %nan, where %nan is greater, or let's say less than 1% missing. Run that, and all of a sudden you'll notice that we actually were able to drop way more features. And let's actually visualize this so I can see the difference. So I'm going to copy and paste this code, come back here, and paste it in. So notice what happened is I had originally a bunch of features here with electrical, garage area, total basement square footage, basement uniform square footage, or something like that. But just dropping electrical and garage cars also dropped a couple of more rows. Here we have 4 rows that are missing 1, and here notice we have 8 features. So essentially, I took care of a problem because these were just bad rows that were missing a lot of information. So let's go ahead and continue with figuring out whether or not we should fill in or drop values. And this is where it's going to be important to understand domain knowledge and take a look at that text data that we opened up to begin with, that is the feature descriptions. You'll notice what's interesting is that a lot of these features that we are missing for just a few rows happens to be basement features. I suspect that this particular 1 or 2 houses just didn't have a basement, so maybe that was the issue. Let's take a closer look again at those basement missing features. So we're going to say df, where df, let's just start with the first one. Let's say basement. In fact, let's actually go with half bath and full bath, since we know those are 2 rows that are missing those. So basement, half bath, and then is, or dot, is null. So I take a look at this one. Looks like it's index 1341 and 1497. Let's check the exact same thing, but now for this other one where we're missing basement full bath. So I'm going to say basement full bath. And you'll notice it's the exact same rows. So the same 2 rows that are missing information about basement half bath are the same 2 rows that are missing information on basement full bath. What will be interesting is now to check basement, this UNF square footage. So let's go ahead and check that one again. We'll say basement UNF square footage, run that, and it's also 1341. So clearly I should either just drop these 2 rows or possibly be a little smarter about this and think of the fact that all of these features had to do with the basement. So let's take a look at what it means for basement full bath to be null, which means I have to come all the way back up to this description and then search for wherever basement happened to be. It looks like it's in more or less some sort of order here, so I'm going to scroll down until we actually find where we're describing the feature basements, either full bath or basement quality, etc. So we can already see right here, basement quality, NA indicates no basement. I can also see again, basement condition, NA indicates no basement. Basement exposure, NA indicates no basement. So it's going to keep scrolling down here till we get to the units that we're looking at. We see basement UNF square footage, that means basement unfinished square feet of basement area. I'm starting to think that it's very likely that these houses didn't actually have a basement, which is why they're just null values. So instead of dropping those 2 rows, how about we perform the following? We do see that there are numerical basement columns like total basement square footage that's unfinished, type 2 basement finished square feet, etc. All of these, if they're null, let's just go ahead and set them equal to 0. We'll kind of operate on the domain knowledge assumption that it's very likely this particular house just didn't have a basement, so they left it as null. And in our case, we can go ahead and safely say for the numerical ones that that's going to be 0. And then what we're going to do is for things like this basement quality and basement exposure, etc., where they just left it as null, we'll go ahead and fill it as none, a string, because notice the rest of them are actually string categorical values as well. Later on, we will need to figure out what to do with these strings, but it makes sense not to just drop it because it doesn't have a basement, but instead fill it in with a string like none for not having a basement. The way we can do that is we'll come back down here and we'll do the following. I'm going to do 2 separate operations. One is going to be for the basement numeric columns, and the other is going to be for the basement string columns. So for example, basement quality would be a basement string column, basement numeric square footage would be a numeric column. And what I'm going to do is essentially fill those null values for the basement numeric columns as 0. What does that actually mean? It essentially means I'm doing a lot of work for just these 2 rows. Possibly it makes more sense just to drop them. You're going to save yourself a lot of work. We are doing a lot of work here just for these 2 rows, but it is kind of a freebie because the dataset feature description says that it is labeling those as null on purpose. So what we're going to do is create a list of the basement numeric columns, and I'm actually going to copy and paste this. I already did this work earlier, and it is a lot of rows, but essentially what you have to do is go through that description file and list out anything that has to do with basement that is also numeric. So for example, basement finished square footage type 2, unfinished square footage, total basement square footage, and whether or not it's a full bath or half bath included in the basement. All of those are numerics. They're either 0 or 1 or some sort of square footage measurement. Then what we're going to do is take our data frame, df. Recall we already dropped electrical and garage cars from this data frame, the ones that were missing those values. And then we're going to say basement numeric columns and set it equal to df basement numeric columns and simply fill NA with 0. And we're going to do a very similar thing for the basement string columns. So those are things like basement quality, basement conditions, etc. I will do and copy and paste the exact same thing just to save us some typing time from the lecture notebook. So I encourage you to also copy and paste from the lecture notebook for this sort of thing. Again, all I did here was I created a list of the columns that had to do with the basement that were string columns or categorical columns. So like good versus poor versus bad basement quality, condition, exposure, basement finish type 1, and basement finish type 2. And then what I did here is instead of filling them in with zeros, because I already know these are strings, I'm going to fill them in with the string none. Note that this is a string none. It's not Python's keyword none. So I'm just filling this in with a string instead of just keeping it null. And now we'll go ahead and run this. And what we just did is essentially fixed, hopefully, these two rows. So now if I were to run this command again, asking where in my data frame do I have a null value for basement full bath, you'll know it worked if it gives you back 0 rows, because that means that we actually filled in basement full bath up here when we actually did this command of fill NA0. In fact, let's see how much data we're missing now. What I'm going to do is rerun this cell, but also I need to recalculate %nan. So I'm going to redo this visualization, but at the same time, we're also going to scroll back up here and recalculate the %missing off this df data frame that has now been updated for us. So %missing off this data frame, grab %nan, do this visualization again. Notice I'm just limiting from 0 to 1. There we go. And now we can see that we essentially solved the problem for almost all the features that are missing less than 1%, except for mass VNR type and mass VNR area. So we need to go back and figure it out for these two features. And after that, we are no longer in the threshold range where I can consider dropping rows. And I'll have to take an approach thinking based off the columns, not the particular rows that happen to be missing this information. So it's a bit of a kind of distinction there between thinking about rows to drop or change individual values from rows, where I have a very low percentage of information missing. For things that have a very high percentage of information missing, I want to start thinking about it based off the column. Do I just want to drop this column itself if I'm missing so much information from it? Or is there something I can be clever with and start to fill in those values? So let's take a final look at what mass VNR type actually means. We can come back up to the description.txt file up here, and eventually after scrolling through it, you'll see that it has to do with the masonry veneer type that is outside the house. What we're going to do is we're going to make a domain knowledge assumption that if we were missing mass VNR type and mass VNR area, again that masonry veneer, then I'm just going to assume that it didn't have one. And there is an option for none here, but for whatever reason, it didn't happen to be filled in for just a few rows. Let's go ahead and just fill it in as none, and then fill in the square feet as 0 for those rows that don't happen to have masonry veneer type. So that's a pretty reasonable assumption to make. What we're going to do here then is the following. I'm just going to do the same commands as we did before. Take mass VNR type. Recall this is the string category of what kind of type it has, whether it's stone or something else. And we'll say mass VNR type. Go ahead and say fill NA as none. And this string is very carefully chosen because it matches what is to be expected based off the description text file. So you can't just be anything there. And then for the other one, which is area, a numeric column, we'll say mass VNR area is equal to df mass VNR area, and in this case, fill NA with 0. All right, we'll recalculate %nan equal to %missing again on this new updated data frame, and hopefully what we see now is everything is above 1% missing, which means we'll then have to consider it based off the columns. So we run this again, And there we have it. So which means I can get rid of this y limit, take a look, and these are now the feature considerations I have to do. We could start dealing with these garage features just by dropping them, but they're above our 1% threshold, and we don't feel comfortable dropping that many rows of data. So we'll have to start figuring out, do I fill in these values for the garage features that are missing? And then for these ones where most rows are missing information, do I fill it in with something like a 0, or do I just drop the column itself because, let's say, most houses don't have pools or don't have an alleyway, etc. Okay, lots of considerations to make. We'll talk about it more in the next lecture. I'll see you there.